Now that we have our reads mapped to our reference, um, you would think that we're most of the way there, but we're actually not even close. We've got a lot of work to do um, for this alignment. Now, the first step that we want to take now is after all the reads are mapped, still contained within those reads are the Amplicon primers. And we have to remove those. And we remove those with a trim primers and dimers from mapping function. So let's try to find that right now. We'll add element, and we have trim primers and dimers from their mapping, from the sequencing analysis. So we want to add that element, and let's clean things up. Let's make a little space for that. Let's put this up here. Move this out of the way because that's just a solitary step there. Make some more room. You can see how easy it is to drag these things around. We're going to be using this mapping report, so we'll keep that around. And for the trim primers and dimers, we're going to feed in the reads track here. So we can delete the reads track and then bring it over to the read mapping input. Now there's two other pieces of information that we're going to need for the trim primers and dimers method. One of them is going to be a reference sequence, and another is going to be a primer sequence. Now the reference sequence we have right up here. We've already used that as input, so we could put this into the reference. Let's move this out of the way. And we have to get a primer track in here. So if we double click and we look at help, and we know that we have a primer track, and we know that we have to import those primers. So what we'll do is we'll back out of this and look at our import functions for primers. So we'll hit import, and there's actually an import primer pairs button. We'll hit import primer pairs. Right now, let's just clear this out because we're going to start from scratch here. And when you come in, you have a generic format and a QIAGEN primer format that you're going to import primers in. And these are going to be your V3 primers that were used for the Arctic Amplicon sequencing. So if we hit help here, it talks about the import primer pairs. And let's open this up a little bit, the generic format. And here's the generic format. The generic format, column 1 is this, have to have reference name, column 2 is the 5' position for primer 1, 3 is 3' for primer 1, likewise for 4 and 5, the 5' and 3 end for primer 2 with respect to the reference, and then an Amplicon name. And what's important to note here is that right here it states primer position intervals are left open and right closed. So the leftmost position of the primer on the reference, columns 2 and 5, should have 1 subtracted. And I'll show an example. So right here where it's saying that where you have this definition that the actual positions that are covered are the ones that are listed here. So 42 to 65 actually covers positions 43, includes 43 through 65. And where we get these primer sequences is pretty straightforward. We can go to, let me pull up the Arctic site. So on GitHub, there's an Arctic network protocol. So here's the, github.com, Arctic network, Arctic NCOV 2019. We could look at primer schemes. We could look at version 3. And the file that you want to use here is the scheme bed. Now the scheme bed file will have the reference, it has the positions, and you could have you have your Amplicon name and whether it's the left or the right Amplicon. So what I've done is I've taken this file and converted it into a text file in the format that is asked for here. So column 1 is the reference name, column 2 is the 5' for the first primer, 3' for the first primer, 5' for the second primer, the reverse primer, 3', and you notice here the numbers go from smallest to largest. Here you go largest small because it's a complement, and then a name for the Amplicon. So what I'm going to need to do, and I'll probably have a separate video just on this primer design alone, because you could spend half an hour more talking about this. But I will make this file available within the tutorial bundle. So we're going to import this in. Okay, so let's remove the help, and we'll say generic format, primer file. If we go back to our SARS-CoV tutorial files, if we look in the reference, this is where we can find the V3 primers. So we'll select that, we'll open, we'll say OK, and then we're going to want to save this. So save, and we'll save it into, here's our SARS-CoV-2 tutorial. We're going to go into our reference and save it in here. Okay. So now that this is saved, for the primer track we can say here, connect to workflow input, and we'll rename this with a right click and say V3 primers, and we'll double click on it to configure it. And going to reference, select the V3 primers, finish. So now we need to configure this module. So we have the primers, we have the reference, we have the mapping input, and we open it up. And right now we're going to use most of the defaults. We're just going to change one factor. So we're going to say minimal primer overlap fraction of 0.5. You can optimize this depending upon how your sequencing performs, what library method you're using for Illumina. The one thing we want to uncheck is the only keep reads that have hit a primer. So we want to remove that because we can have reads that won't hit a primer. Most of you will be using, say, a Arctic V3 protocol and then using a DNA flex, and there's definitely a chance for a lot of reads that don't have a primer contained in there. And we'll leave the defaults at 9 and allow a dangling 3' end. Once again, you can go into help and look at what all those parameters mean. And we will say finish here, and then we'll define a single output, which is the read mapping output. We're going to save this, save as, we'll call this step for trim Arctic primers. Okay, and there's our completed workflow. Validation successful. So let's try to run this. We'll take our reads that we've been using all along. The reference is chosen, primers are chosen. We're going to save into results, and we'll create a new folder in there. We'll call this step 4 trim primers. Finish. And this should zip along pretty quickly. You can see the progress down at the bottom, and then also has the different modules laid up. So we're just finishing up the map reads to reference. Now we're trimming the primers. And done. Okay. So if we go back and look at our results and into the trim primers, this is our new set of reads, our read mapping file, and it looks similar to our read mapping file as before, except now the primer sequences that were part of the amplicons are trimmed down. So if we, kind of remove a bunch of that coloring, we could see here's our current read mapping with the primers removed. Okay, so from here on, the next few videos, we're going to go a little bit into indels and structural variants, and then reperforming a local realignment based on some guidance from those indel and structural variants, and then move on to basic variant detection. Thank you.